All right, hello everyone. Good morning, afternoon, evening, nighttime, whatever time you're watching this. How you doing? Today we're going to look at a nifty little relationship between a function's slope and its inverse's slope. I originally had a discovery activity set up so we could work through this in class. Here's what I will tell you up front. You should be able to do this entire front page, no problem. On the next page, then I kind of have some tables as a way of organizing things. So what I want you to do, at least um, before watching the rest of the video, I want you to at least try the front page here. Won't take you more than a couple minutes. It's two derivatives, a couple like an old school, hey, find the inverse of this, and go ahead and start the video up again. So pause it, try it, please. All right, so here we go. Your original point should be 2 comma 8, and the derivative at that point is 12. We know the definition of an inverse function is just where you switch the domain and range. So if the original function has the point 2 comma 8, then the inverse should have the point 8 comma 2. For the derivative, or well, first then I had you take the inverse, which just flip around the cube becomes a cube root. So there was our inverse function. And then with deriving it, okay, you had to use the power rule, but thankfully no chain, no, nothing like that. And then I had you evaluate it in two places. And at the same x value as where you found the original slope, remember I had you find f prime of 2, there was no relationship between this irrational number and 12. But when you find the slope of the inverse at 8, that was the reciprocal of the slope at 2. Weird. Let's organize this if you haven't already. Turn the page. So here's how I like to organize this. I just make a quick little chart where I've got the points and the slope, and then I've got my original function, and I've got the inverse function. This just helps me keep track of things. So look at it when it's laid out like this. I got my flipped x and y, of course. I have the slope at the original x, and that is the reciprocal of the slope at the original y, or the new x. So let's see, could we generalize this pattern here a little bit? So remember, this happens, this happens. I mean, we've known that since algebra 1 or 2. And then if the slope at this x value is 1/4, then the slope at the corresponding point on the inverse, so again, the corresponding point would be the one where you just flip the x and the y, would be the reciprocal. That's pretty convenient, huh? Okay, so now let's say there's a couple more things we don't know. Okay, so we can easily come up with this, right? We know how to do this. We have a function. Yeah, I can find a point. I've been able to do that since 6th grade or whatever. I don't know. I don't teach elementary school, middle school. And then we've been able to find the slope of a function at a point for a couple months now. So I know the inverse would contain the point 6 comma 2. And then I know on the inverse, the slope at this 6 value, well, that was kind of a weird sentence, would be the reciprocal of the slope at the corresponding original point. So the slope at 6 on the inverse would be -1/7. It's just the reciprocal. People love to say opposite reciprocal, just the reciprocal. Let's turn the page. Okay, so now AP loves to do this. They just give you like, here's a whole bunch of information, do something with it. So here you go. Suppose f and g are inverse functions. Suppose you've got this information. Then our job is to figure out the slope of the function g at its x value 4. Well, what do we have? Okay, we know they are inverse functions, so this handy-dandy little rule is going to apply. On my original function, I have the point 2 comma 4. And I know at that point, at f of 2, or at f prime 2, the slope is 3. Okay, so then g of x has the point 4, 2, and I know the slope at 4 has to be the reciprocal of the slope of the original function at 2, which would be 1/3. We can generalize this a little bit here. The key thing is the two functions have to be inverses. If two functions are inverses, then their derivatives, their slopes, derivatives, are, how would we describe this? They are, how about, or they're reciprocals. Reciprocals at these mirrored points or corresponding points. Corresponding points, the ones where you have x, y, and then the two value switches. How about let's not use x, y, let's use a, b, and then on the other one it's b, a. Okay, you're gonna love this. Here's another way of proving this exact relationship. So again, by definition, f and g are inverse functions, right? That's just a setup to this whole problem style that we're looking at. And way back in Algebra 2, your teacher so meanly made you prove that the two functions were inverses by verifying that both ways of composing them gave you x. That is to say, if you have f and you plug g of x into it, you had to get out x, and then you take g, you plug f into it, you also had to get out x. And you were like, why could I do this when I could just solve it algebraically? We'll check this out. So let's look at this guy here. Let's derive f of g of x. So that would be a chain rule, right? You got one function inside another, so it would be derivative of the outside, keep the inside the same, times the derivative of the inside. And then, okay, that would be one side of our equation. Remember, you can derive both sides of an equation, so that's our left side of this one. I'm looking at this one that's circled. Now I'm going to derive the right side. The derivative of x is 1. Okay, so let's set these equal to each other. If I'm working with this and I derived both sides, so d dx d dx, I have f prime g of x, g prime of x equals 1. Let's rearrange a little bit. Now, sometimes we get lost in the function notation. Function notation typically represents y values, right? This thing right here, g of x, if I had a number to plug in for x, that would be a y value on the function g. So couldn't we rewrite this as f prime of some y value times g prime of x equals 1? And then let's solve for g prime, because I mean that's kind of what we're always doing here. We're tasked with finding the slope at some other function, right? So let's solve for g prime. G prime of x then would be 1 over how strange. Look, it's the x and the y. It's the reciprocal of the slope. Oh my goodness. Wow. Wow. Isn't that amazing? Isn't that the most amazing thing you've seen today? Okay, let's make sure we summarize, condense. Let's put this kind of together formally, and then we'll call it a day. So we got one regular page, regular looking stuff. Here we go. So what I've got up here is just kind of a general walkthrough of the same thing. We've got a function of x. I've also given you the inverse. It's cube root, and the first one's cubed, so hopefully they're probably related right there, right? Let's derive both. So f prime of x would be 3x squared. The inverse of f derived, evaluated at x, would be, let's see, now this is really a power of 1/3, so my 1/3 would come down. Inside stays the same, negative 2/3. Don't have to chain rule because the derivative of the inside is 1. Then let's evaluate those in a pair of places. So f prime of 3 times 3 squared, 27. And then the inverse's derivative evaluated at 1 would be a third times 27 to the negative 2/3 power. Well, really that's just 1 over 3 times the cube root of 27 squared would be, oh yeah, because I want to do that. I want to do that the other way around. I want to cube root first. I want to cube root 27 and then I'll square it. Because I know the cube root of 27 is 3, and then 3 squared is 9, so I have 1 over 27. Amazing, it's the same relationship as the previous page. Let's put it together. Same exact thing. Okay, here's really what it looks like. No, this is not really. Typically, this would show up just like as a multiple choice question on the AP exam, and you're good to see this like once every year. So hey, it's free 2 points on the AP exam, right? or 2 1/4, however, they multiply by a decimal. That doesn't matter. We got a function. Let's find some points. Let's find some inverse stuff as well. Here's how I like to organize it. Point, slope. So on the previous page, I gave you the tables, right? And then F inverse. So let's take a look at, we plug in 1, we get 1 plus 5 plus 1 plus 5. Shocking. 1, 12. And then, okay, I need a derivative for my slope. F prime of x would be 5x fourth, 15x squared plus 1. Slope at 1 would be 5 plus 15 plus 1, so 21. Okay, so then I don't have to do anything with the inverse to actually solve this problem. I know the inverse is going to contain the point 12, 1, and I know the inverse's slope at that point is going to be the reciprocal of the one above. Done. Easy. All right. Hopefully that wasn't so bad, and I'll talk to you tomorrow.